Good evening. My name is Oscar Gutierrez, a master's student at CETIS Tijuana, Mexico. And on behalf of my co-authors, I'm presenting the paper, Pensando, Developing a Smart Pen Assessing Handwriting Skills. So to start, we're gonna talk about dysgraphia. Dysgraphia is a disorder of the writing ability. It can appear at any stage in life and might manifest in different ways, including problems with legibility, letter spacing and spelling, problems with fine motor coordination, slow writing speed, and pencil grip and writing posture. When children fail to develop efficient handwriting, their academic success might be severely affected. That's why there are some dysgraphia tests to measure handwriting skills. The diagnosis is usually made in an educational setting by professionals. One of the downsides of these tests is that they depend on human judgment, which makes the test subjective. An alternative is a computer analysis, which has proven to be more effective, but equipment and software are more expensive than traditional handwriting evaluations. There is alternative technology for people with dysgraphia, such as keyboards, which is useful for those children with sensor, motor, speed, and legibility challenges to help in the writing production. Another one is dedicated voice recording systems, which could also support the writing needs of children with disabilities, but would require a fine speech skill. New technologies have been emerging for characterization of handwriting. In Sarah Rosenblum's case, she uses an electronic table to investigate handwriting patterns to differentiate between children with diagnosed high-functioning autism spectrum disorder and their typically developed pairs. On the other hand, we have smart pens. These are usually equipped with nasal sensors and gain attention for handwriting recognition, but are currently used mainly for characters detection. To the best of our knowledge, none of these have been designed and used to assess children's handwriting. That's why we propose Pensando. Pensando comes from the word pen and sensando or sensing in English. Also, Pensando in Spanish means thinking. Pensando is a smart pen with the purpose of detecting a child's handwriting ability in a cost-effective manner. We have found that some studies indicate that writing speed is a contributing factor in predicting legibility, while slow speed might be an indicator of dysgraphia. That's why we include an Arduino Nano PLE Sense, which is relatively cheap and easy to obtain and includes the motion sensors that will be needed to do this measurement. Force control when manipulated on a pen is significantly correlated with the final performance of the motor. Therefore, we included a force sensing resistor to measure the pressure when grabbing a pen. Pensando consists of four models. The first two, sensor pen and data acquisition, are currently being developed. The other two components, data processing and classifications, are the ones that will allow the assessment of the writing skills and are work in progress. The sensor pen model includes a 3D design and sensor inclusion, which we already seen. The data acquisition model involves the reading of the sensors with a Python program and saving them in a .csv file. We want to carry out studies in a real environment. For that, we need a tool that can be useful for the evaluator, so we developed this interface. The idea is that the assessor can control how the information is saved. Another function it has is to see in real time what is captured while the child writes. In the video, we can see a light graph of the gyroscope, the accelerometer, and the pressure sensor. In the data processing model, we will prepare the data by filtering and starting the feature extraction. In the last model, we will use the features to train the machine learning classification to assess handwriting skills of children. To understand the experience with Pensando, we conduct a pilot study with two neurotypical children with the ages of 6 and 9 in a home setting. We began by asking consent to participate from both parents and the two children. After that, we invite the children to grab the pen and we ask them to do the following activities: write their names, write the current date, draw cycles, and travel lines. After completing the activities, children were asked to rate their experience for user satisfaction using the 5 degrees of the happiness like scale, the smilometer. Based on the comments, both children's responses were mostly positive, but they also suggest the possibility of personalizing the pen and getting more feedback. Overall, the results of this pilot evaluation show that children can write using Pensando and find it easy to use. With the collected data, there are two main approaches that Pensando will allow to do. One is to classify whether the handwriting skills are from children with dysgraphia or not, and two, continuous assessment of the handwriting skills. As children, we will use the pen. We design Pensando with sensors and actuators that are lightweighted, do not heat up, and are size appropriate for children's hands. Moreover, the sensors and actuators were carefully selected to be a cost-effective tool that can be affordable for different contexts. The future work will be the collection of data from children with or without dysgraphia, creating a machine learning model to classify their handwriting skills, and deploy the system in a real scenario. Overall, in this paper, we present the design and development of Pensando, a smart pen augmenting with sensing capabilities that will allow us to assess each child's needs while developing handwriting skills. And that's our reference used in this presentation. This paper was made in a collaboration between CETIS Universidad and Chapman University. Thank you for your time and for coming to this presentation. I will be happy to answer your questions.